So this is a problem from section 6.6. Find the moments about the x-axis of a wire of constant density that lies along the curve y equal square root of 2x from x equal to 0 to x equal to 2. So we know moments can be found by finding the sum of the multiplication of mass time distance of that from where we are trying to find the moments. So in this case we have a curve and the distance of that curve from x-axis is y. That's how we can find the distance. So let's say if we divide this wire into different discrete masses like mk, as you can see here, then the distance of this mass is the value of the curve at that point. So basically we're trying to find the sum of all these masses times the distance of that mass from the x-axis, because it's about the x-axis. So which can be found by finding the integration of this mk times y. In this case the range of integration is going from 0 to 2. Okay, so mk stands for mass for this object. Mass can be found by multiplying the density times length. In this case it's a length, it's actually mass is density times volume, but in this case it's a wire, so the mass can be found by multiplying the density with the length of that wire. For that particular piece we can find the length of a wire or a curve by using this d of s, which is actually square root of 1 plus dy over dx whole square. This is a formula from length of a curve. Okay, so basically now we need to differentiate y with respect to x and find this d of s and plug the value back here and do the integration. So in our case dy is y is square root of 2x. So the derivative of y with respect to x is, you can keep this square root of 2 outside and find the derivative of square root of x, which is basically 1 over 2 times square root of x. If you simplify this square root of 2 from the top and bottom, it will give you 1 over square root of 2x. Okay, so we found dy over dx. We need 1 plus square of dy over dx, so just square this thing, which is 1 over 2x, and add 1, and that is going to be square root of 1 plus 1 over 2x. Now we're going to plug this value back in the formula moments about x-axis, which is density, which is given delta constant, times the integration. This is the length we found from here, and then the y, which is the distance. This is where I'm plugging the value mk times y. But in our case y is a curve, which is square root of 2x. So now we just have to simplify this. You can just combine them, just distribute this 2x here, because both of them have the same radical, so you can just multiply. It will give you 2x, and if you multiply 1 over 2x times 2x, that will give you 1. So now this is just a simple integration. We are going to use substitution. Let's substitute u equal 2x plus 1, and by doing that we can find out the du, which is 2 times dx, and eventually dx is du over 2. We're going to replace this dx by du over 2. We're going to replace this 2x plus 1 by u, and this limit of integration will also change. When x is 0, u is 1. We can find that value by plugging x equal to 0 here. And then when x is 2, 2 times 2 is 4 plus 1 is 5. So now this is what we need to find integration for, and integration of square root of u is u to the power 3 over 2 over 3 over 2 by using simple power rule, and by using the fundamental theorem we have to put u equal 5 minus u equal 1, and you can bring this 3 over 2 as a 2 over 3, and this 2 and this 2 will be cancelled out, and finally delta over 3, 5 times the square root of 5. 5 to the power 3 over 2 can be written as 5 times the square root of 5 minus 1. So this is the moments about x-axis.